Providing courses that lead to good job prospects for their students has become a major preoccupation of universities and colleges. The needs of potential employers have to be carefully balanced with meeting required academic standards. To this end, the Mathematics Academic Group in the Faculty of Computing at London Metropolitan University has invited a group of practicing mathematicians from a range of industries to advise them on the makeup of their degree courses. Group leader Dr. Pargat Singh Kale takes up the story.
I've always been interested in what happens to our students, why they're studying mathematics. There are few who are studying because it's a beautiful subject, but most are studying at this university to improve their lot, which means they've got to get employment and jobs. And that's only possible, or rather the greatest chances are if they know, if they can offer the industry what the industry wants. Therefore, one way to know that is ask them. Here's what we are offering, here's what we intend to offer, tell us if it serves your needs.
It is clear then what the university is looking to achieve, but what about the industrialists that make up the advisory panel?
It's important to establish links between commerce, industry, the professions and academic programmes so that one feeds the other with either what it's doing or what it should be doing and new ideas, etc. They're different operations, so there always will be some sort of disconnect, and it just helps from time to time to bring people together to actually join things up again a little bit more.
I think it's really very useful to help prepare undergraduates for employment. As an employer, it will increase the breadth of the market available to me. I think there's some personal satisfaction also in helping younger people to get their first step on the employment ladder at a time when job opportunities are not that easy to come by. I've seen a number of applicants for posts recently where I've been a little bit disappointed by some of the ways in which their personal statements on their application forms have been written. And if I can help students to develop that so that they can produce more quality applications and stand a much better chance of employment, then that would be great.
I was quite surprised that the university was interested in industrialists coming and looking at what they're teaching to see if it's relevant, because for us as employers, it's very important for the graduates to be the kind of people we're looking for, because especially recently we had a few jobs for applied mathematicians come up, and we interviewed a lot of people and we couldn't find anyone suitable. So actually this is investing in our future as well, trying to get the graduates that are coming out more suitable for us.
It isn't just about the maths, it's about all the disciplines that maths spreads into, and so engineering is also an aspect of that. And we are very supportive of the fact that we do need people who are good with numbers, and unfortunately our perception is that fewer and fewer children are engaged by that and want to take that through. So it is important that those of us who use maths in our day-to-day lives promote that and make sure the next generation carry on doing what we do.
The London Metropolitan University has a long history of offering degrees with a strong vocational element. That emphasis arises in part from the atypical demographic of their central London catchment area.
Well, London Metropolitan University is a university which is serving the poor people and the group of people who may not otherwise be getting the qualifications or the education that they need. So it's a very important, essential social service as well. I think students' view is more focused now. They know that job market is shrinking. Therefore, if they don't grab the right job at the right time, they may be left behind. And one other thing that I think average age of students at this university is a lot higher than at other places. It is not so-called a traditional age. Therefore, they're already behind 2 or 3 years, the other graduates. Therefore, for them, getting a job as soon as possible after graduation is really important.
At the London Metropolitan University, there are 5 different Maths B.Sc courses on offer, which are all biased more towards applied themes than pure mathematics. These degrees are Mathematics, Financial Mathematics, Mathematics and Computer Science, Mathematics and Statistics, and Mathematical Sciences. Each degree has its own distinctive elements, although some modules are common to all. Prior to this, the first meeting of the industrial panel, the panellists have been sent details of the content of all the modules, together with the expected learning outcomes. Interestingly, the responses from the panel are varied, with some members concentrating on specifics of the content, while others are more interested in the range of modules on offer and in broader issues like communication skills.
One of the things I see, especially in my job, but I think across lots of industries, is more and more we're looking at people collecting larger and larger sets of data sets. So there's a lot of data collected, stored in what they call the cloud and big computers and stuff. But a lot of people at the moment are just collecting. They don't know how to analyze this. They don't know what to do with it. And the traditional kind of maths that we've been taught in university won't help, because they're large, they're sparse, they're noisy. You can't run anything to test it quickly on one computer. So there needs to be a new generation of mathematicians who can deal with this type of data. So that's what I've hoped to try and steer at least some of the courses to, developing these kinds of mathematicians who can deal with that kind of data.
I was really looking at the statistical content, and I looked at this from two particular points of view. One is, how can you perhaps attract students to study more statistics modules so that you produce a greater number of students with these essential skills in statistical analysis. And secondly, of course, how is the programme of the degree suited to employers' needs? I'm really glad that you are focusing on the applied end of the statistics spectrum and the use of computer packages and so on. And some other, I've made some other suggestions really geared at trying to make the very first exposure of students to statistics a really exciting thing.
The emphasis I took on this was not so much looking at it from the point of view of an undergraduate going through a degree, but I much more thought of it from the point of view of an employer who might be interested in putting some of his employees on, sending to your modules. And that's really where my split is. So, for example, study skills for math. Someone going from school to university as an undergrad, that would be quite good, but I don't see an employer being that interested. They would expect that to have been done, I think. So my list there is really ones that I think offer something meaty to employers who will be willing to shell out for it, rather than thinking, oh, they should know all that already.
From what I've heard so far this morning, I think I'm looking at it slightly differently. I think most of the people in the room do have a maths background, a pure maths background, and they're much more interested in the content and how it relates to the maths that they use in their day-to-day lives. I'm looking at it more from an employer's point of view and trying to think. I take the maths for granted almost in this course. I accept that the people who are lecturing it know their job, but what else can they do to make the maths undergraduates more employable in the wider field?
I don't want someone coming up to me saying, look, I've got a degree that tells me I can write the CV, because they're going to send me the CV, but that's the skill they've got to have. And they've got to get the foot in the door, so the CV's got to catch my attention, and then they've got to excite me when they come in for interview. I know when I did my degree, it took me a long time to grow to get any confidence, and I feel for the students of today if they're not being given that. Well, I think you are providing that.
I think sometimes the brightest of students feel that they might be able to get by on the basis of their level of attainment alone, and but it isn't that, because one always has to say why it is you want a particular job. We want people who are interested in the post, not just those that have a very high level of attainment. I think universities also, particularly in the past, I don't think it's so true of this university, but tend to have most of their courses on detailed mathematical or statistical techniques, with very little opportunity for students to present their findings, to engage with clients, if you like.
If you were to present these course specs to your employer and say, this is what I've been doing over the last 3 years, what aspects would impress them and what aspects would they say, well, you know, not necessarily going to pick you over someone from a different university for that purpose. I think there's a split in terms of your employability content between things which support the student while they're at university and things that will continue to support them in the real world content, in the workplace. And so I've tried to split that out, and I think in terms of your employability and additional bits to the core maths, there's certain things which are really going to help students sell themselves on their CV in an interview, and they can demonstrate I've worked on real world problems and I've got the programming background and I can therefore do all of these other things. And the other bits which I think are really useful to students who are making that transition between school and university, but which really don't form part of something that you would necessarily want to then share more widely. The modules cover quite a range of different things. One of the things I found quite difficult at university was actually picking out modules which would then support me in my chosen career path. So, for example, if you want to get a job doing X, it's really beneficial for you to be doing this set of modules, and being able to make that really clear, and especially with all the different paths that you've got, just making it really clear what career paths that enables you to go down could be potentially useful both for the students and for employers when they come into employment, if they've got that one piece of missing information that they could have done and they didn't think of doing it.
A novel approach is being taken to encourage students to become more involved with industry at an early stage. This is part of a university-wide initiative referred to as the Work-Related Learning module.
This is really a new concept, that we would have a module that is more like a vessel into which you tip any form of work-related learning. So they could be doing volunteering, service learning, placement, especially set up work-style projects within the faculty where they're required to operate as if they're working in a company, or other aspects that might be particularly relevant to mathematics. But it must be truly work-related. Rather than talking about work, it must be enacted in a way that is like going to work. So it's a different philosophy. Rather than employability, it's experience of the work environment.
It would be a good outcome of this committee if a few embryo suggestions, not fully thought out ideas for projects, or indeed independent learning options, just ideas that people could either take or not take if it was feasible. So,
And I think we would want to be flexible about that, so that the student would anyway have a supervisor at the university, and the involvement of the company could be small or large, depending on what was. They might be just proposing the idea, or they might involve visits to the company. We could do it anyway. Really.
Whatever. Yeah.
The opportunity is greater now because we have this work-related learning module. The course development teams are nowadays very conscious of the fact that they have to bring in the work-related issues into their degrees. It's not like let's do the sort of degree and then go to work. You know, people are beginning to see that from year one, basically, because large number of students actually come into, at least to our course, this kind of units to improve their lot. There are few who might come just because they enjoy it, because mathematics is beautiful, but vast majority do come to think, you know, at the end of it, I will improve my position, and that means a better employment.
There is general agreement that well-chosen industrial placements are of tremendous value to students and to employers.
Having placement students available is potentially useful for employers as well, because they're cheaper than hiring someone full-time, and makes recruitment potentially cheaper as well to get people in. If you've just driven them already.
Process, haven't you?
Well, exactly. So at the moment, I mean, I think even more than usual. I know my university offered it, and I didn't take it up, and I was fortunate that I found something anyway. But most of the people that did a placement year were in much better stead to go into university, and that was a number of years ago. So
I mentioned Derby just now. Derby, if you don't want to do the placement year, you actually have to justify why not, rather than the other way around. You know, it's expected that you do the placement, and they're talking similar numbers to yourself.
Another outcome of this that I hope will be an outcome is that we can ask some of you to come and talk to some of our students, because hearing from you that it's very important to be able to see them in situ in the work environment, and that's good for them and gives them the opportunity of employment, is a strong message. They'll take that message much more strongly from you.
It's early days, and this is only the first meeting of the industrial panel, but everyone is optimistic about the future.
At the end of the day, we can train them as much as we like, we can put in your ideas as much as we like, but once they're graduated, what really matters is what you do, what the industry does.
What's out there.
Okay? And that's where, if you like, we are the spectators, aren't we? We say we had 100 students, how many of you are you going to employ out of that? We can just quote the figure. What we can do is produce the kind of people that you will find useful to employ. And hence these kind of meetings are for that purpose. So we can design our curriculum and at the same time have the knowledge that underpins your needs and needs of industry in general. It was nice to be surprised that people working in industry are enthusiastic about what goes on in the university, what's being taught to future students. And they put in a lot of hard work to think through what would be needed and how we can implement that within our existing framework.
I've got 3 outcomes in mind. One, improvements that might be made to courses here to produce undergraduates who are better prepared for work. Investigate the possibility of working with local industry in upskilling the workforce, and finally to have some sort of input into suggesting research directions that the department might look at if they feel they're equipped.
I think the industrial panel is a great idea, and I really applaud this university for wanting to go ahead with that. It certainly does have the potential, I think, to be of great value to students. And I think we've already seen some examples where colleagues have agreed to come and talk to students, and I certainly would be very willing to do that. So I think from a number of points of view, it's going to be a very successful venture.
But I think maybe in the past there wasn't that much of a focus on the degrees, on how it relates to industry. Nowadays, more of a focus, because even in academia now, they're forced to think of the impact of their work rather than just the course content and the research content. So it's becoming more important, and so they're shifting, but I think it's taken a while.
I hope that the people who represent the university will get some good ideas. I think already this morning there's a few things which they will have figured out for themselves. That, that all of these ideas are not unique to us, but maybe we're helping them to see the importance.
Just having us here now, we're all now involved. We have a kind of a feeling that we're part of this network, and we want to help the university do better. So we'll propose projects, for example, and we come and give talks and things like that. Those networks are hard to build, and these kind of things are useful. And for the industrialists as well, it's quite good for us in terms of our personal development and our career progression to say we are on an industrial panel like this. So it works both ways. It's a win-win.
I now have more idea of what sort of outcome I should be achieving in terms of qualified students in order for me to contribute towards the industry that these people are working in. There may be some of the things that we may not be able to fit in, not because we don't want to, but because of the space, the time, and other pressures. One of the things that I have to make sure is that our degrees also satisfy the quality benchmark, so which may take up space, otherwise that I would have used on the problem for industry. But we will maximize the opportunities discussed today. We will continue to communicate with each other, and these people will be talking to my students in more detail, and then students, by talking to these people, will be able to do their work in the sense of projects and other areas in a sort of practical world. That way we will continue this contact, and I think this relationship will continue for a long time.